Hello everyone, this is Dr.V.V. Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we will do some problems related to the gear trains, finding the velocity of the components. The learning outcome for this lecture is, at the end of the lecture, students will be able to explain about finding the velocity of the components in epicyclic gear trains. Now, let us take one problem here. You read the problem once. An epicyclic gear train or gear contains 3 gears A, B and C as shown in the figure. So, in some problems directly the diagram will be given and you will be given some data and you need to calculate the problem, some components. But in some problems we need to identify how the structure of the gear train will be. We need to draw the diagram, right. The gear A has 72 internal teeth and gear C has 32 external teeth. The gear B meshes with both A and C and is carried on the arm EF, which rotates about the centers of A at 18 rpm. Now the problem, last one, if the gear A is fixed, determine the speed of the gears B and C. Look here, in this problem, we need to identify in this epicyclic gear train, right, this gear. So, what is this one? The central one, right. The central one we need to identify this as, generally we call it as the sun gear, okay, or otherwise you need not remember exactly what is sun, what is planet, no problem at all. This is only for the convenience, right. So, gear E is there and gear F is there, okay. I will give some other color, yes, okay. So, in the earlier problem we discussed only the epicyclic gear train confined to 2 gears only, right. So, first gear, second gear connected by an arm, right. Now, if you give some velocity to gear at E, right, you can call gear C and gear B, that is it, okay. E and F are the center of gear C, F is the center of gear B, right. Okay. In our earlier discussion, if the velocity of C is given as some 100 rpm or something, we are able to find what is the velocity of gear B, right. Now, we need to extend our discussion to gear A also, right. What is gear A? Gear A is annular gear or ring gear, we are calling with the name ring gear, right. This ring gear will have internal teeth, right. This one has internal teeth. So, around this periphery we are having internal teeth, okay. Now, how the gear A will rotate? I will show you. Just I am taking this small part, okay. This part I am taking meshing between B and A, right, to the last right side last part, okay. So, this is the gear teeth that are on, I am drawing at the bottom. So, this is regarding gear B, right. Now, what about the gear C? Not gear C, gear A, the ring gear, okay. So, the ring gear will be like this, okay. So, I am drawing with the green color. So, this is the ring gear, right. On the ring gear, I am having internal teeth. Internal teeth means whatever the gear you are making on the outside, it is external. It is, if it is inside, it is called internal teeth, right. Like this, I am having internal teeth that are cut on. So, you can look this. So, these are all internal teeth, okay, not exactly to the same specifications. So, I had drawn for your understanding. So, if you draw a circle, if this is the gear A, how the teeth will be, just it is like this, okay. So, these are all internal teeth. Now, how the rotation will be transferred between C to B and B to A? When C rotates in one direction, automatically the B will rotate in opposite direction, right? But what about the B and A? When B is external teeth and A has internal teeth, they will rotate in the same direction. If the direction of the B is, okay, let it be, B is rotating in clockwise direction, right? Let it be, right? When C rotates, because we are taking anti-clockwise positive, suppose I am taking C is having one revolution anti-clockwise, right? So, plus 1, let it be. Immediately the B will rotate in clockwise direction, okay. Now, the gear A is stationary, let it be, right. Now, how the gear A will rotate? B will induce the energy to A and A will rotate, right. How it will be? So, you can see this is clockwise. Look at the bottom diagram. So, this one, right. So, B is rotating clockwise. Now, what the B will do? The B will induce some force on gear A, right. So, this gear will induce some force, okay. So, the B will drive the gear A to clockwise direction. So, by applying some force on the teeth of gear, internal teeth of gear A, the B will drive internal gears of A to move clockwise, right. Got the point? So, B is rotating clockwise and it will induce the internal teeth of the gear A to rotate the annular gear or the ring gear also in clockwise direction. Same thing will be in anti-clockwise, right. So, the direction of B and A, they will be the same, right. Okay, this is regarding how the energy will be transferred. Now, you can calculate one by one, okay. See, the gear A has 72 internal teeth, C has 32, right. Now, the remaining you can calculate the regarding the B also, okay. Now, you see in the diagram, you can start with the C or B or A, whatever it might be, right. So, you can prepare the table. How the table will be? First one will be the same, right. Arm fixed. Now, the gear C rotates through one revolution, right. So, starting with the central one, we are transferring to C to B and B to A, right. So, first component is arm, second component C, third component gear B. Up to this only we discussed in the earlier problems, right. Now, you are having A also. Now, the gear A, okay. So, three components other than arm, right. Okay, arm C, because it is a fixed one, 0, right. Gear C will rotate with plus 1, right. Okay, now you look here, gear C is rotating plus 1, that means anti-clockwise 1, right. What about the rotation of B? It will rotate in opposite direction, right. Because it is rotating in opposite direction, B will have clockwise, right. Now, what is NB? NB by NC is equal to TC by TB. When NC is minus 1, so NB will become minus TC by TB. That is what here. This is actually NB. Because of the directional reversal, we are making minus, right. Okay, after that, what about gear A? Now, you have the direction you can see. Of course, the speed relation will be the same, direction only, either same direction or the opposite direction, but NA by NB is equal to TB by TA, right. I want to have the relation Na by Nb is equal to Tb by Ta. That's it. Okay. What is Nb? You substitute it because I don't know the exact value. So Na is equal to Tb by Ta into Nb. What is Nb? Minus Tc by Tb. So you need to multiply with this. So Tb which gets cancelled, minus Tc by Ta. This one you cannot make the direct equation Na is equal to minus Tc by Ta, right? You need to derive it because the direction will be changing, right? C to B it is changing, B to A same direction. So Na is equal to minus Tc by Ta. The first row that is to be filled with utmost care. After that everything is automatic. What is the second step? Arm fixed, gear C rotates through x revolutions. So all the components are to be multiplied with x. So 0 into x is 0, 1 into x, minus Tc by Tb into x, minus Tc by Ta into x. Now what is the third component? Add y revolutions to all the elements because I am rotating arm, right? Initially the arm rotation will not be there. Next we are making the arm to rotate. So add y revolutions to all the elements, plus y, plus y, plus y, plus y. Now what is the total summation? Fourth one is always equal to 2 plus 3 only. Now this is 0 plus y, x plus y, y minus x into Tc by Tb, y minus x into Tc by Ta. After making the table, now you need to go back. What is the data given, right? So what I need to find? I can find the velocity of gear C, gear B, gear A, right? The gear B measures with both A and C and is carried on an arm EF which rotates about the center of A at 18 rpm, and gear A is fixed. Okay. So arm is rotating at 18 rpm. It is given plus 18, right? So when you are taking the plus 18, so it is anticlockwise, right? So y is equal to plus 18. Next another one is given, gear A is fixed, gear A is fixed, right? So B cannot induce the gear A to rotate in clockwise direction. So we are fixing the gear A, right? Then what is the condition for B, right? When gear A is fixed, y minus x into Tc by Ta will become 0, right? So y is equal to 18 rpm, this is the first equation. Second equation, y minus x into Tc by Ta equal to 0. So substitute y is equal to 18 here, and Tc by Ta, what is Tc by Ta? Number of teeth on gear C will be 32, on gear A will be 72, right? So substitute in this and get your x is equal to 40.5, right? Now the speed of gear C, when you got your x and y, then you can find the speed of gear C and speed of gear B. What is gear C? X plus y, right? You can write here NC is equal to x plus y, then it will become 58.5 rpm in the direction of the arm, right? Initially we are taking plus means anti-clockwise, right? Next I need to find gear B, right? If you want to find the gear B, I need to have the equation y minus x into Tc by Tb. So Nb is equal to y minus x Tc by Tb. Y is given, x is given, Tc is given, but Tb is not given. Tb is not given, right? So the number of teeth on gear B I need to find, right? So what is the relation? The relation we need to identify from the diagram itself, right? So what's the diagram? You can see in the diagram, you will look here, okay. So what is the relation between the radius or the diameter, right? Okay, I am looking here. See, I am taking E and I am taking the edge point of A, right? Okay, better I will take some other color. Okay. Now you look here. So I am drawing a line through the arm, right? A dark color, right? So center point to the last point. What is this actually? Radius of A, right? Radius of A, right? RA is equal to. Now what is this? RC. RC plus. What is this point to this point? 2 times radius of B, right? So this part is 2 times radius of B or diameter of the B. So 2 RB I can write. RA is equal to RC plus 2 RB, right? So convert into the diameters or the radius, whatever it might be, right? So if you convert this into diameters, so this is dB plus dC by 2 equal to dA by 2, right? So dA is equal to, so diameter of A is equal to dC plus 2 into dB, okay. So the same thing you convert into the number of teeth. So 2 TB plus TC is equal to TA, right. So from this I can get the number of teeth on B, we got here 20. So substitute in the y minus x into TC by TB, then I will get gear B rotation will be minus 46.8 RPM, right. So this is in the opposite direction of the arm, right. So the summary of this lecture is student can calculate the velocities of the components in epicyclic gear trains under given conditions. Thank you.